Assalamualaikum and hi everyone. Today our group are going to present about one of GIS tools which is QGIS. Before I start, I'm going to introduce my team members first. First is Dinagaran anak lelaki Mohan, Muhammad Alif Ifzam bin Muhammad Azam, Nur Khuzairi bin Bacok, Anis Syakirin binti Syaha, and me myself, Alia Syazwani binti Khairul Anwar. So, in this presentation, we are using one of the GIS software which is QGIS. QGIS allows us as a user to manage spatial data, create thematic map, perform spatial analysis, and visualize changes. Our group presentation will be about metallic tin ore in Malaysia for year 2016 to 2020. So, the QGIS we will be using will help us to visualize changes in mineral distribution over time. As we can see, QGIS is widely used due to its flexibility, accessibility, and strong analytical capabilities. In addition, WebGIS platforms are used to share and visualize spatial data online. For example, Mapbox and Leaflet. This platform enable interactive maps that can be accessed through web browser, which making spatial information easier to communicate. In this presentation, we also use some plugin for mapping the mineral easily, such as QuickOSM.
Okay, as of my part, I'll be explaining the application. So first, GIS helps us map and visualize where tin ore deposits are located in Malaysia. So using QGIS, we can easily identify areas with higher tin mining activity. This is very important for understanding the spatial pattern of mineral resources. Next, we have temporal analysis, where GIS allows us to compare data across different years. By looking at the maps around 2016 to 2020, we can observe changes in tin ore distribution, such as increase or decrease in the mining activity. Then next up we have geological interpretation. Tin ore deposits are closely related to geological features. This allows us to overlay tin ore maps with geological data, helping geoscientists understand why tin occurs in certain areas. Next up we have environmental impact. So this is useful for assessing the environmental impacts of tin mining. Mining areas can be analyzed in relation to rivers, forests and settlements. And lastly we have land use and decision supports. So finally, GIS supports land use planning and decision making. Authorities can use GIS maps to manage mining activities and promote sustainable resource management. So in conclusion, GIS is an important tool in geoscience for analyzing the spatial and temporal distribution of the tin ore in Malaysia. Thank you.
Okay, so now we're moving on for part comparison and evaluation. So for this part, first in terms of usability, desktop GIS is mainly used by geologists because it supports in-depth geological analysis such as ore deposit, which is for our data age tin ore, mapping and spatial modeling. This is important for identifying potential tin ore zones. On the other hand, WebGIS is easier to use and allows data such as tin, mining location, and concession boundaries to be shared quickly through a web browser, especially for non-technical users. Next, for scalability, desktop GIS can handle large and detailed spatial datasets locally, such as geology layers, but it is limited to individual computers. In contrast, WebGIS is cloud-based and can support many users at the same time. This makes it suitable for collaborative mining, planning, and data sharing between agencies. In terms of accessibility, desktop GIS requires specific software and training, such as ArcGIS or QGIS. WebGIS, however, is accessible anywhere with an internet connection, making it very useful for field teams and community stakeholders to view mining maps and reports. However, there are some limitations. Malaysia's tin production declined between 2016 and 2020, which resulted in limited and outdated spatial data. In addition, production data is often scattered across different agencies, causing poor GIS data integration. To address this, several improvements are suggested. A hybrid GIS approach can be used, where desktop GIS handle detailed ore analysis while web GIS supports data sharing. A centralized cloud-based tin production database should be developed, supported by mobile GIS for real-time field data collection, and improve web GIS analytics with offline capability. So, integrating both desktop GIS and web GIS can improve monitoring and decision making for Malaysian's tin mining industry. So, for our data, from 2016 and to 2020, the production rate of tin ore decreased. That's all from me. Thank you.
So next is the digital skill showcase. Use of spatial data. Spatial data is data that has location information, which is coordinate. For tin ore studies, spatial data show tin ore deposit location. In QGIS, this data is displayed on a map with real-world coordinates. Secondly is use of layer. Layer are different map information stacked together. Each layer represents tin ore occurrence point. Layer can be turned on and off to focus on specific information. Third, use of symbology. Symbology is how features are styled and visualized on the map. In QGIS, symbology helps users understand data easily. For example, tin ore deposit shown in circle point. Different symbol and color help identify pattern and distribution of tin ore. Next is publishing a web-based map interface. GIS help access environmental. QGIS allow maps to be exported. Map can be shared as firstly interactive web maps and online GIS platform. where users can zoom in and out, click on thin arrows point to see the information, turn the layer on and off. This makes thin or data easy to access, interactive, and user-friendly. Next is the use of analysis tool. QGIS analyze tool help to analyze spatial relationship. This tool helps to identify potential thin or zones. Okay.
So now for conclusion, the key insight is by using QGIS map, show how obvious highlighted Western Thin Belt area. The data show two distinct spatial issues. First one is ex-mining land that require rehabilitation. Second one is current extraction site that risk water quality. And then QGIS demonstrate that even a small extraction site in the highlands can impact water quality for millions downstream, which highlighting the need for buffer zone mapping. And for future direction, like where should GIS analysis ensure sustainable mining? First is having real-time water quality monitoring, where it allows authorities to detect if effluent discharge in real time rather than waiting for public complaints. And remote sensing for rehabilitation, where we monitor the greening of its mining site, which this helps track the success of reforestation if effort over time. And for lastly, reflection learning experience. While working on the thin or extraction project, I learned that spatial data is a living document. By transitioning from static map to a web-based GIS platform, this map isn't just a record where all is, but a tool for environmental, social, and governance accountability. Seeing the special extent of mining footprint made me realize the power of GIS in helping Malaysia balance its mineral wealth with its natural heritage.